Alright, so we're going to finish up the multi-loop example from in class. Sorry if I sound a little stuffed up. I feel a little congested. So we're going to start by looking at the junction on the top. I'll put a dot there. And we're going to examine the current flowing into and out of this junction. We just have to arbitrarily decide directions of current flow. There has to be one current that goes out, and there has to be at least one that goes in, and the other one could be optional. So I'm just going to arbitrarily decide that this current on the top right coming in, we're going to call that I1. Coming down from the junction, flowing out, we're going to have I2. And flowing to the left of the junction, also leaving the junction, we're going to have I3. It doesn't really matter what direction you label these as, because later on, if the current is supposed to be in the opposite direction, we will come up with a negative value for the current. Let's take a look at the bottom junction as well, and all we have to do here is follow the established rules already. Coming straight down the center, we have I2. So now I2 is going to be flowing into the bottom junction. I3 flows around counterclockwise and would also be flowing into the bottom junction. And I1, if we follow I1 backwards, we find I1 needs to go around here, also counterclockwise, so I1 would be leaving the bottom junction. Now if we look at Kirchhoff's rules, the current going into and going out of a junction must be equal. So current going in has to equal current going out. And if we look at the top junction, the current going in is I1, and the current going out is I2 and I3. So we get I1 equals I2 plus I3. At the bottom, we have I1, which is going out, and I2 and I3, which are going in, so we get I2 plus I3 equals I1. In both cases, it's the same equation, so I'm only going to write it down once. And again, that was I1 equals I2 plus I3. Current in equals current out. Now we're going to go around and look at the voltages and how the voltage changes and drops around the loops here. It's important to note a few things before we start that, though. First of all, if you go over a resistor in the same direction as the current, your voltage is going to drop. So V drops over a resistor going with the current, and the opposite occurs if we go against the current. V raises going over resistance if you are going Okay, so in this circuit there are 3 loops, and we'll deal with them one at a time. We're going to start with the loop on the left, and I'm just going to arbitrarily choose a starting point. So I'm going to put a dot here. That's my start point. I'm going to choose a direction to move around the circuit. So I'm going to go around the circuit in this fashion. And every time I go over a resistor in the direction of current flow, it'll be a voltage drop. Every time I go over a resistor opposite the direction of current, I will have a voltage gain. And the battery, if you go from negative to positive, voltage gain. If you go from positive to negative, voltage loss. And remember that the plus is on top. In this battery, the minus is on the bottom. So for this first circuit, we're going to get, or for this first loop, we're going to get from our start, we would go through R1, but we're going against the current. The current was going to the left, we are moving to the right, so that's going to be a voltage gain. So I start off with my voltage across that resistor equals IR. R is 4, so I'm going to have 4 I3. Then the next thing we do, we just hopped over there, we're coming through. Now we're going to go through resistor 2. This time we're going with the current, and it's no longer current I3, it's I2. So this is going to be a voltage drop of 2 I2. And then lastly, we come around and we go over the voltage supply from negative to positive, so that is going to be a voltage gain of plus 28 volts, and we're back to our starting point, and so that's got to equal out to 0 voltage difference. We're going to do something similar for the next loop. And from the start point, I'm going to circle around this way. For this battery, minus on the bottom, plus on the top. So for this second smaller loop, from our start point, we go up. First thing we're going to have is resistor 3, 1 ohm, and we're going in the same direction as I1, so that's going to be a voltage drop. So we will have minus 1 I1. The next thing we'll encounter is going through resistor 2 in line with current 2. So that will be minus 2 I2. The next thing we come to is going across our voltage source from minus to plus. That will be a 7 volt gain, and altogether those equal out to 0. We do have one large loop to consider still, the big loop that goes around the entire circuit. However, this doesn't contain any new information that isn't already in our equations. And if you look at the 3 equations that we have over here, we have 3 unknowns, I1, I2, I3, and we have 3 distinct equations. So now the only thing we have to do is solve this system of equations, and the very first thing that I'm going to do is take our first equation and I'm going to substitute it and rearrange a little bit, and when doing so I will get minus 3 I2 minus I3 equals negative 7. That came from the substitution. And then I'm going to take that and multiply by 4. This will set up the addition method later on, because I can see that this has a 4i3 and this has a negative i3, so then I'll be able to cancel those terms out. So I'm just doing this in advance to keep things a little more organized. So when I multiply by 4, I'm going to get negative 12i2 minus 4i3 equals negative 28. And I'm going to take our red equation now and just rearrange it a bit. So we have minus 2i2 plus 4i3 equals negative 28. So I've got those equations together. I'm going to take these equations here, add them together. That'll give me negative 14 I2 equals negative 56, and I'll get my first solution, which is I2 equals positive 4 amps. And because it's positive, it means that I2 really does go down through the center of this circuit. When I take this result and plug it back into the equations, for instance, taking I2, I could plug it in here to find I1. I could plug it in here to find I3. No matter what I do, I'm going to find that I1 equals -1, and I'm going to find that I3 equals -5. And for those two problems, the negative flows opposite. So that means that I1 should actually be flowing to the right, and I3 should actually be flowing to the right as well. So these problems will work out no matter which way you choose your initial current flows. Just be aware, if you get negatives, it means it's the opposite direction than you may have originally indicated.